Hello and welcome to another video. Today we have a Mac X670E Carbon Wi-Fi on our bench AM5 socket from a viewer actually called Florin, I think. Yeah. And he bought this off of a company used, and he was in the belief that this was working. And he had it laying around for some months. And then when he actually tried it out, it wasn't working. So let's figure out what is wrong with this board. He upgraded from AM4 to AM5. And let's see what then is wrong with this. Very well packaged. Let's get this box out of here. So this thing looks beautiful. Very ginormous board and very heavy. But yeah, looks great. Big question, what can be wrong with this? If I understood his emails right, he said something of this doesn't boot up, and I'm not too sure if that means that it has no reaction to the power button, or that it boots but gets like stuck on a CPU LED or something like that. And first thing I would think of is obviously broken components, because this board has so many components everywhere and is very heavy. Like when building this into a computer, you can very easily damage parts by trying to put this in somewhere and it being really heavy and like getting stuck somewhere with it and trying to force it in. Yeah, so far nothing obvious that I see just with the blank eye. But I think we will go as usual. We can start also from the back for checking the V-core circuitry. So let's do it a little bit differently this time and start with V-core. So we take the upper part of the 12-volt connector. We put one probe on there, and then we just find a ground point. And we have kilo ohms and rising, as you can see. And then we take a point of the V-core VRM, like the capacitors, for example, and we have also kilo ohms and rising. That is very good. So V-core is not shorted. Let's then go further with the 24 pin from the front in order to see what might be wrong with this. So let's see right here. We start from the 3.3 volts, which is bottom left. Let me get a good ground. So 3.3 volts, kilo ohms and rising. That is good. 5 VSB, fourth pin from the top. Oh, this camera always just focuses on my hands, man. Kilo ohms and rising. Then second pin from the top left, which is 12 volts, I think. Kilo ohms and rising, and 5 volts right next to it. Also kilo ohms and rising. Okay, we don't have a mainline short. That is already good. Let's check 3 VSB. We can check 3 VSB very easily on the PCIe connectors if they are open like this one. What you can do is you have this notch right here, and the first pin to the left of that is 3 VSB. And I cannot probe it. Yeah, I cannot get contact into there. Cannot reach the pins, okay. We not getting a reading. Okay, well, that's fine. Let's then go further to have a look at the socket. I don't think the socket has anything to do with this, because he would have mentioned that. Yeah, the socket looks immaculate. That is good. Let's then get the heat-sinking brackets out of here in order to plug a CPU into here and see for the passive power consumption. That is the next thing that can give us most clues about what is happening on this board. We do have quite some on-site debugging with like the segmented display and with debug LEDs. So we don't need to plug any of our own in here. I gotta say, this board is like, this has all of the features. This really is a high-end board. Like, this must have been cost quite a fortune. But before we get to repair this board, let me thank our today's video sponsor, which is PCBWay. They help us they sponsor our channel so that we are able to make PCBs like these 3 PCBs that I have right here. This big one that you can see right there is, for example, a switch panel box. This one right here that I'm using, that takes the ATX 24-pin adapter and puts out different voltages to, for example, banana jacks and a fan header and some barrel jacks and a USB even, and has switchable inputs and outputs. And this is the version 2 board of that. This is the version 1 board of that. And also, there's this breakout PCB, this small PCB that is actually in the current meter devices. And yeah, they do more. They do 3D printing, sheet metal fabrication, and so on and so forth. But most importantly, you can get your PCBs from them. And I'm very thankful for them as a sponsor, for a very long time sponsor on this channel. And enabling me to make my own electronics with their PCBs. So thank you very much for them. And let's get on to fix this board. So time for our test processor, a 7500X. So let's get this careful into here. So we have a CPU in here. Let's get the passive power consumption to see how this board is behaving. And hitting the button, 150 milliamps. That looks very fine. So 150 milliamps, I wouldn't expect there to be anything wrong. Let's get a stick of RAM then into here. Let's populate A2. So I'm very interested now if this board will boot up. Interesting enough, this doesn't have an onboard power button. I would have expected that it has something like that. Let's also get a speaker onto here. So I'm very interested if this has a reaction to the power button now. Let's hit it. Okay, it doesn't have a reaction to the power button. Okay, so I did understood him right. That is our problem actually. Okay, do we have... I do not see a BIOS battery, so that we could reset the BIOS instantly. But there's a clear CMOS button on the back. Let's hit that. And you can see the power consumption going down. And now it is up again. And we cannot, it doesn't react still. Okay, so this basically means we have to take off basically almost all of the heat sinking, especially in this area right here, in order to get a better look at this board. Because I would definitely first expect knocked off components around the CPU socket and maybe around the PCIe slots. That is what I would expect. So we will have to get all of this off in order to have a good look here. So let me start doing that. So I've taken out most of the heatsinks. For now, I don't think we need to take out the heatsink for the PCH, but I think I saw something already that I want to investigate. So we definitely need to go under the microscope next to check some things out. Okay, what I expected is actually just some dirt right there. So I didn't see that quite correctly. So let's have a good look then. One of the places I would expect is around like PCIe connectors, because people tend to go there with screwdrivers and then knock stuff off, but this looks so far fine. And these are like the PCIe 5.0 switches. These are really expensive. Like they might have gone down in price a little bit, but yeah, when these first came out, these were like, I think around 14 bucks for a single one of those, and I had a board where like 4 of them were shot, which is really expensive. Are those scratches on here, or is that a logo? That might be a logo of that. This board is so packed with components. This is insane. Like there's so much to damage here and so much to check. That is... These AM5 boards, especially more high-end boards, are quite beasts. So this looks kind of like an SIO, but this is probably just an LED controller and then a driver next to it. But those can also interfere with the boot sequence. And so far, nothing really to be seen anywhere. So far, the board looks very clean. Let's go have a closer look to where the power button is. There's anything knocked off here, but this also looks good. Let's check now. This is closer to the DDR sockets now. For some voltages that should be generated here. But it looks fine. Use now a USB-C controller. And now close to the 24-pin adapter. I gotta say, this board has so much connectivity. This is really insane. So many things, like whatever the heck this is. Okay, this kind of looks like someone tried to solder to this. Because do you see that? It looks like solder. Weird, weird. Still, so far so good. Like, the spot looks clean, mostly. Let's have a look. We are at the CPU socket now. Now PWM controller. That is mostly hidden. Let's see, to the 12 pins connectors here. Everything there, okay. Let's have a continuous look around here. So far this board looks very clean. But as you know, a single component can be the cause of this issue. A single resistor that is missing. I'm rather interested in the backside of the board, to be honest, to see if there's anything missing there. But yeah, but having the overview of this board is quite difficult because it's just so packed with components, just so many things. But let's then go to the backside and have a good look at that. So, backside of the PCHs, but these are mostly just capacitors. This being X670, this has two B650 PCHs on it, but it definitely looks like, is this just packaging material or was someone here before? This might be that actually someone had taken off those heatsinks before, and that we will have to take them off as well, just to make sure that there's no damage caused there. Like, this backside of this board is packed. Like, there's so many components. Like, on AM4, you often had it, there's like just a few filtering caps. But this one, this has a lot of stuff. Like, with this amount of components, it's so easy to miss if you knock one off, or like if you're searching for something that is knocked off to not see it. Interesting, a little bit of damage here. So something has been on the backside, definitely, because the solder mask is definitely scraped a little bit. But so far I cannot see any big scratches or anything like that where maybe some traces got damaged. But this is definitely an indicator that probably someone did try to put this into a case. And as always, especially around screw holes, is very interesting to have a good look, because that's where people interfere with these boards. The V-Core has actually quite some components here on the back as well. And for all of the inputs and outputs at the back, there's also quite some circuitry here. It's then kind of difficult to... Oh, yeah, okay. Yeah, well then. Yeah, here's the actual hit that has happened. This right here, I have seen that a IC in the top right of the board is responsible for power faults. So this might be a power fault IC that monitors different signals and then prevents power on. And if it is missing, for example, a voltage, it could trigger a power fault where it says some signal is missing and I'm not letting the board then turn on. We still have that resistor actually there. let's see if we can find out what this resistor actually is. So let's go on to here. 10 kilo ohms. Okay, so if anything, there needs to be a 10 kilo ohm resistor there. But let's see if we can get this resistor soldered back onto there. Because it might be broken to the point where the ends will not connect properly anymore. But let's see. Or let's just get rid of it and put a proper 10 kilo ohm resistor. Like 10 kilo ohm resistor is nothing. Let's just get rid of it. So let's see right here. Yeah, it was basically just hanging on by a thread. I'm not comfortable also using that resistor anymore. So let's get a 10k ohm resistor. So I actually used up all my 10k ohm resistors for the current meters. So I don't have any 0402 10k ohms anymore, new ones. So I took one off of a donor board and here it is. Let's now tag it onto here like that. Let's get the other side also soldered on and then reflow this into place. So just getting some solder on there. Let's now take the hot air. And let's now, you need quite some heat for these boards. Even though this is just a 0402 component, but still you will need quite some heat. This is 450 degrees at 70% airflow. And now you can see it springs back nicely. That means it's properly on there. So especially while it's hot, let's clean this off. So board is nice and clean. And now you can basically can't really tell that the resistor was broken ever. Let's see now. We want to go from that point to right here and see 10 kilo ohms. That is great. And I want to see this. Did this one get a hit? I don't think so. Oh, this might be a higher than 20k ohm. Let's go in a higher range. Yeah, 100k. I just saw it. Yeah, 100k. So that is also fine. Because if one component is ever knocked off, like there can be more damage in this area. And like it can hide on different components that it doesn't really look like it was knocked off or anything. But I think this is actually all for the damage here. So if I can get a board, we will definitely have a look what this does. Let's continue a little bit with the search because there could be more broken off. It is unlikely, but it could be the case. So let's see a little bit further also. This is all VCore VRM and this looks fine. And no components fitted here. Yeah, and there's nothing here anymore. Okay. So yeah, I'm very interested now. Oh yeah, I missed one more spot. This one I missed. But this also looks fine. And the backside of the CPU socket itself, also fine. Okay, let's then go and see if this board now reacts to the power button. So how great would this be if this is actually the fix of this board? I haven't had a proper easy one in a long time. This would be a classical good fold. And it would make me really happy if this would now react to the power button. There's no rabbit hole that we have to go down here. So let's see now. 150 milliamps of power consumption. Let's hit the power button. It does react. Oh, it didn't react in the first second and I was like, no. But it does react. Oh, that is so good. I'm so happy. Let's get the post screen into here. Oh, that is so great to see. Let's see, is the post screen enabled? The post screen is not enabled. Let's get that into here. I didn't hear post beep yet. I do have the VGA plugged in, so the HDMI. I don't see any. The boot LEDs don't have any indication currently. We are stuck on 64. No idea what that might be. Let's then see for... Yeah, USB indication. If this board already booted or not. So USB indication, no USB indication. Okay, so we probably need to reset this board. It's stuck on something. So resetting once, CPU, DRAM LED. Let's see, 4.7 apps, and there is the post screen. It updated, but why is it gone now? Why are you gone? It comes up with this boot screen and then goes away. What is this? And it's stuck on 3.8 amps. That is so interesting. What is happening to this board? This might need a BIOS flash, to be honest. No idea. Probably the owner tried something. Let's turn this off. And oh, there, it just posted. Ah, man. Yeah, okay, no. It just needed a little bit of time to catch itself. Just be a little bit more patient. So yeah, this was probably RAM training or something similar to that. When it's on 64 and then takes 3.8 amps. The power consumption just looks so stuck, but it seems to go further. So let's wait this time a little bit because we went further to 0 after 64 at the top here. And I got to say that segmented display looks so good. That looks like white LEDs. Yeah, 99, there it is. That looks so clean. And there's the actual boot screen. Let's hit the Y button. And let's get into the BIOS then. And let's get into the setup then. And there's our BIOS. Let's see. From the 21st of February 2024, the BIOS. So let's do this customer a favor, and if he wants to install new CPUs, let's flash the BIOS that is on here. Let's see if this has a way of flashing the BIOS internally, like through Ethernet, but I don't think so. Let's see right here. So there's a M flash that we can choose. Enter flash mode. Okay, we will have to download the BIOS. Let me quickly get a BIOS for this. So let's enter flash mode then. I got a thumb drive now connected with the latest BIOS on here. It's very interesting that these boards always have to, like the AM5 boards, always have to reset in order to be able to get into a flash mode. That is very interesting that it now works like that. Like the RAM needs forever every time to get into this. Like very weird behavior. They can very surely there are some improvements to the like boot up sequence for the DDR on this board with doing BIOS updates. So this is definitely a good thing to do. And we're entering flash mode right now. That is very great. Let's see right here. So let's choose that file. It is quite laggy right now. Let's see. I want the flash disk. Yeah, I want this flash disk and this BIOS file. So we go from E0 to R6. BIOS are updating very well. Let's leave it at that and get you back as soon as the BIOS is updated properly here. So the BIOS is updated and now the board is booting for the first time with the new BIOS. So that this viewer will also have the newest BIOS in here, so he can throw whatever processor he wants into this and have the latest and most stable BIOS version. So I was actually able to get a hold of the board view for this board. And this is the backside, as you can see right now. And this is where our damage was. This is this 10 kilo ohm resistor. And this is called RT9553 proc hot. Proc hot is a very important signal that that is responsible for turning the board on very early. And I'm not quite sure what this controller does. It says something of a timer, some signals, some reset, some some reset signal, the proc hot signal. I'm not really sure where all of this is connected to and where this goes. Let me see if I can find something. Yeah, this goes on, for example, on the front side for enabling. Yeah, this is probably just for enabling a lot of different things. Yeah, there's multiple controllers. There's another NCT controller that is connected to this one. Let's see, to this to these resistors. Yeah, this takes, for example, SIO voltage into it. Then let's see what else is there connected to. VCC5. Yeah, it looks for different signals. Yeah, this is somewhat of a monitoring chip that takes different signals in. And based on that, but what can it disable or enable is the important question. Nothing to be seen here. If this is like also to the SIO again connected. Interesting, okay. But the most important thing is we have a proc hot signal. And this proc hot signal could, because this 10 kilo ohm resistor was missing, it is connected to 5 VSB on this side and then creates that signal. And the most important thing is this transistor on the front side where it connects to. Because this transistor, its gate is being enabled by that. And there's something called power fault, just like I thought. Because I have seen that multiple times that chip or that area is responsible for a power fault trigger right here that you can see. And there's the proc out and a flag also. And this then probably at the end pulls down some enable signal or something like that, which it would be easier to see this if you have like a board view. But what essentially happens if this power fault is then high probably, and where's it to connect it to, this power fault? Oh yeah, to that transistor. Yeah, I've seen exactly that. So if this gate isn't enabled, these and this doesn't get connected to each other, so power fault is always high, because if this gate is enabled, it pulls this down to ground, which is S2 here, and if this has power, then yeah, then the PS on is not being connected here anymore. Probably something like that. Because what you can see here is the PS on being connected to the PS on from the SIO. And if you have a fault here, yeah, and if you have a fault here, this cannot be connected to each other, and then the SIO tries to pull down the signal, the PS on signal, but it gets stuck at this transistor right here. And there's the board in the BIOS with now the newest version from the 22nd of October 2025. And yeah, I'm not going to be trying to get this into BIOS or anything, because into Windows and test anything, because this was quite an obvious fault that this was actually what was happening and going on with this board. And all what is left for me now is to build this board back up in order to have all of the heat sinking on here again. But yeah. So it took me actually quite some time to get this back together. Like, this is somewhat of a puzzle to do, but yeah, it came back together nicely. I now want to see if this board boots up with 3 sticks of RAM in here. I'm very interested if it can do that. Because we had it before on a board where 3 sticks of RAM wouldn't boot. And this looks very similar to that. That you can get 2 sticks working, but 3 sticks wouldn't. It's currently RAM training, I think, or trying to reset. I'm very interested now. Oh no, this looks fine actually. Yeah, it can. So this board can boot with 3 sticks of RAM in AM5. Because the previous one that I had, where only A2 and B2 was working, I couldn't get 3 sticks to work. Interesting. If this might be, like, this is a different chipset. This is X670. And the other one that I had that couldn't boot with 3 sticks of RAM only was B650. So I do not know if that is still a limitation here or not. Huh. But yeah, this is my usual experience, that I know that even if you don't do the optimal RAM configuration, it can boot. And this what was making me doubt that the other board that was actually working fine, where A1 and B1 wasn't working. But yeah, on this one, it definitely does do that, and it can get further. And the board is already booted. It just takes some time to get into the BIOS. And yeah, and there's our BIOS screen. And now running with 3 DIMMs of memory. Very interesting. I want to see the memory configuration here, if it shows that properly. Yeah, right there. Shows all 3 sticks of RAM. Very, very interesting. Well then, this is actually a very, very common fault. I've seen this multiple times, that the board doesn't power on because of that area where the resistor was sitting, because I think this is a MSI thing to put that power fault management chip there, and I've seen it multiple times that the VCC of it gets broken or something else, and some resistor is just missing, and that's why PS on is not passing on the logic right there. And this happened on AM4 boards as well, and on Intel boards, I'm pretty sure. And yeah, this fault is more common than you think, because knocking off components off the backside just happens all the time. It happens very easily. So yeah, this can just be. And at the end, let me thank once more the sponsor of this video, PCBWay, for making it able to make my own PCBs. As you can see, here are 3 different PCBs that I was able to make via their services. And yeah, thank you very much for them, for sponsoring our channel, that we can do more of these repairs and make our own electronics also. And as always, all of my tools are linked in the video description if you want to get one of these current measuring devices and the software. This was also made together with PCBWay. This is the actual PCB that will be inside of there. And yeah, all other of my tools are also in the video description. Thank you very much for watching, and goodbye.